You know, it's funny. Sometimes the biggest secrets are hiding in plain sight, in the simplest shapes even. Like, what if I told you that the good old cube, yeah, just a plain box, holds a mathematical puzzle that was cracked almost 2,000 years ago?
All right, let's jump right in. What you're looking at is a perfect cube, but it's been taken apart into just three really elegant pieces. Now, you could try to put them back together, that's the puzzle part, but the real magic, the mind-blowing part, is the math. See that green piece? It's exactly, and I mean exactly, 1/2 the cube's volume. The red one is 1/3, and the purple one? It's 1/6.
And that right there, that's the big question, isn't it? I mean, sure, it's cool to see the pieces fit together, but how on earth could anyone prove those exact fractions, 1/2, 1/3, 1/6, way back in the 3rd century? Think about it. No computers, no fancy calculators, none of the stuff we take for granted.
Well, the answer lies with this guy. His name is Liu Hui, and he was an absolute genius. We're talking about a 3rd century mathematician who was so important, he's often called the Euclid of China. Yeah, that's how big of a deal he was.
Now, you might be thinking, this was just a fun little side project for him, right? Like he was just playing with blocks. But nope, not at all. This wasn't a toy. Liu Hui was a civil engineer, and he had some very real, very big problems to solve. He needed to figure out the volume of massive earthwork projects. We're talking giant mounds of dirt for construction. And he laid out his thinking in this super important text, his commentary on the 9 chapters on the mathematical.
So to tackle these huge, real-world problems, Liu Hui did something brilliant. He figured out he could break down these really complex, solid shapes into just 3 basic, fundamental pieces. Essentially, he created his very own set of mathematical Legos, his own building blocks.
And the names he gave these shapes? They're just fantastic, so poetic. You've got the Qiandu, which is basically a triangular prism named after an embankment. Makes sense. Then there's the Yangma, a rectangular pyramid, which translates to a sunshine-carrying horse. I mean, how cool is that? And finally, the Binao, a tetrahedron, which he thought looked like a turtle's foreleg bone. Just incredible.
Okay, so the first part of his logic is just so elegant and simple. You take 2 of these green pieces, the Qiandu, and look at that, they just click together, a perfect cube.
So right away, you can see it with your own eyes. No fancy math needed yet. The Qiandu has to be exactly 1/2 the volume of the whole cube. Boom! 1 down, 2 to go.
All right, next up is the red pyramid, the Yangma. We're going to use the same exact logic here. You take 3 of them, and yep, once again, they fit together to make another perfect cube.
And just like that, it's totally clear. The Yangma has got to be exactly 1/3 of the cube's volume. It's simple, it's visual, and it just works.
And last but not least, we've got the trickiest piece of the bunch, the purple Biennale. Now, to make a cube with these, you actually need 6 of them. And there's a little twist. You have to use mirror images for half of them to get it all to fit just right. But when you do, you get this really satisfying visual proof that completes the whole puzzle. The volume of the Biennale? Exactly 1/6 of the cube. And there you have it, 1/2, 1/3, and 1/6. Okay, but here's the thing. Seeing blocks fit together is great, right? It feels convincing. But for a mathematician like Liu Hui, that's not enough. That's not a proof. He knew that. And this is where his true genius really shines. It's all about how he proved the hardest part of this whole puzzle. The real challenge, the linchpin of the whole thing, was proving the connection between the pyramid and that little tetrahedron. He had to show, with cold, hard math, that the Yangma, that's the 1/3 piece, was exactly double the volume of the Biennale, the 1/6 piece. If he could prove that, everything else would fall into place. And his method for doing this? Oh, it was just pure genius. He thought, okay, what if I take both of these shapes and just dissect them? Cut them in half along their length, then their width, and then their height. What he was doing, essentially, was breaking the big problem down into a bunch of tiny, identical, easier-to-compare problems. So to keep everything straight in his head, he imagined the pieces in 2 different colors, say red and black. And what he realized was this. After you cut everything up, the red Yangma had enough little pieces inside to make up the volume of 2 small cubes, with some smaller pyramids left over. But the black Biennale, it only had enough parts for 1 small cube's worth of volume. You see the 2-to-1 ratio starting to appear? But wait, you might be asking, what about those leftover pieces? The little pyramids?
Well, this is the masterstroke. Lu Hui said, no problem. Just do it again. Dissect the leftovers. And again. And again. He realized that if you could just keep doing this forever, an infinite number of times, those leftover bits would become what he called infinitesimal. So tiny they're basically formless. They essentially disappear. And this is just wow. This is an incredibly early peek at the concept of limits, which is the very foundation of calculus. He was thinking about this almost 1,500 years before Newton and Leibniz.
Okay, so let's hit the fast forward button. We're jumping from ancient scrolls to the 21st century because that incredible mind-bending insight from Louis is having a total rebirth, all thanks to modern tech.
And that journey starts right here, on a computer. Using free software that anyone can download, like GeoGebra, you can design perfect, precise digital templates for Louis' 3 shapes. The accessibility is amazing.
And from there, it's super simple. You just print those templates out, maybe on some cardstock, do a little folding and taping, and boom. An almost 2,000-year-old mathematical proof is suddenly a physical hands-on puzzle. It's an absolutely perfect activity for a classroom.
But why stop there? We can take this whole idea to the next level. With 3D design software, we can do exactly what Lu Hui did in his head. We can perform that dissection virtually, splitting a digital cube with perfect mathematical precision.
And then comes the really cool part. You take those digital files, send them over to a 3D printer, and it literally brings these ancient shapes to life. It creates these solid, colorful, and just really satisfying puzzle pieces that you can hold right in your hands, from an ancient mind to a modern object.
And you know what? The impact of this is huge. It really connects with people. Listen to what one future teacher said about it. I also loved the cube puzzle because it was unlike any math I have done before. Not only was I problem solving, but I also got to be hands-on, which was very engaging. And that's it, right there. It connects the brainy part of problem solving with a real, physical experience. This whole story, it really makes you wonder, doesn't it? You have this brilliant proof from Lu Hui, an idea that came from a really practical need, and now, centuries later, it's inspiring a whole new generation, all because we have new tools. Which leaves us with a pretty big question to chew on. How many other incredible ancient ideas are just out there, sitting in old texts, waiting for the right modern tool to come along and bring them back to life?